Alright, so class, this video we are going to cover how to add and subtract radicals. In this video you'll learn the specific rules for adding and subtraction of radicals. Our I can is I can add and subtract radicals. Freeze this if you need to write it on your I can statement. Just a quick review of what we're going to be talking about and some vocabulary words. We're going to be talking a lot today about what the radicand is. Remember that the radicand is that number underneath the radical symbol. And that radical symbol looks kind of like that division symbol. We're going to be working specifically with an index of 2, so we're going to be working with the squared root. So here are the directions. Pause this video, get all of the notes down into your pink notes, and then unpause the video and we'll get going. So first we need to write out the prime factorizations under the radical symbol. We look at the index, and the index number tells us how many we need to be under the radical symbol to equal 1 of that number outside of the radical. We multiply and rewrite. So that's how we simplify. So here's how we factor. Remembering that factoring is the opposite of the distributive property. So we've been learning a lot about the distributive property, especially in 7th grade. Up here at the corner, remember the distributive property is when we have like 3 parentheses x plus 2, and we distribute that in. We have 3x plus 6. Well, that's the same thing as what we're doing, but instead of starting with this situation, we're starting with this situation, the second one, and going to the top one. All right. So, write down in your pink notes all of the steps, and then we'll go over them. Freeze the video. All right, now that you freeze the video, so let's go through this. So first we have to simplify our radicals and radicands. So I see that we are working with a square root symbol here, and we have 45 underneath this radical symbol. So I leave my coefficient of 3 out in front, and then I write my radical symbol, and then I write my times table. It is 3 times 3 times 5. Because it is the squared root, I will be circling 2 numbers that are the same. So I know that the square root of 3 times 3 comes out to be 3, the whole number of 3. If you don't know that, that's okay. You can use your calculators to do that piece for you. We still have the other 3 out front, and then we still have that square root 5. So now I'm still simplifying, so 3 times 3 is 9, square root 5. Now I'm going to bring down this plus square root 5, because I know square root 5 is as simplified as that gets. Now I can actually start talking about factoring out the like term. And in this case, the like term is that square root 5. And then I'm going to put in parentheses. Now, up here, I have 9 times the square root 5. Well, when I remove or divide by the square root 5, what am I left with right here? I'm left with 9. And then I have my plus sign. Now here, when I divide by square root 5, I'm left with a number. And a lot of times we've been talking about that number of 1 timesing invisibly by things. So 1 times square root 5, I'm left with 1 down there. Another really great way to think about this is if I had, well, I'll show you in just a second. So I'm left with 5 parentheses 9 plus 1 is 10. As a mathematician, I really hate how that's written, so I always want to write my coefficient of 10 out in front of my square root 5. Now, just so you guys can kind of see another way to think about this, is if I had 9x plus x, how many x's would I have? I would have 10x. So we're treating our radical, our like term of that radical, like the variable of x. All right, well, let's try a couple more. So here are two examples that are on your notes. We have the first one, so we're just going to start there. The interesting thing about this first one is I see my radical and my radicands are exactly the same. I have square root 4. I can simplify those, but I'm going to choose not to do that right this second. So I'm going to put my parentheses in, and I'm going to move out that square root 4. In the first spot, I'm left with the 3, and then again I have that elusive 1, so plus 1. So I end up with square root 4 and 4 in the parentheses. Now, really, we could rewrite it like this, 4 square root 4, but we wouldn't be done because the square root of 4 is a perfect square, and that equals 2. So we really have 4 times 2, which equals our final answer of 8. There is a couple of other ways to get that done, but that's what we're talking about doing right now. So let's look at number 2. I have square root 3 plus square root 5 plus 3 square root 3. Now, in class, a lot of you guys were saying, well, you have 3's in common. And you're partially correct. I really like the fact you were able to identify that we had all of those things. However, we're not correct because we're only looking at the radicands. And so when I'm looking at my radicands, I'm looking at the things underneath the square root symbols. I have square root 3, square root 5, square root 3. So I only have those two on the edges, still highlighted in blue, are identical. Now, I like to rewrite this problem so then my brain knows what I'm adding. So I'm going to move square root 3 plus 3 square root 3 plus 5. Well, square root 5, excuse me. Now, I see right here that my radicand of square root 3 and square root 3 are the same. So I'm going to combine my like terms by doing the parentheses and moving my like term outside. I have 1 plus 3, and that gives me 4. So I'm going to write it as 4 square root 3. And then I still have to bring down that plus square root 5. Now I cannot combine square root 3 and square root 5 because when they are not the same. They are not the same type of thing. So just like when we were doing our equations, I could not take x and say, let's say I have 4x plus y and get 5x's because I don't have that. That cannot happen. So again, just kind of think of these as our variables. Alright guys, I hope going over this has helped you remember how to do this. If you have any questions, please ask me in class. Bye!